Excited to see more of me and do more multiple choice problems. These ones are tricky, so give yourself the time and like the resources to do well on those. And usually that means drawing a picture, maybe writing some equations down. But I'll go through these together with you since we had to do the synchronous uh, quiz, group test. So I'll go through this right now. So let's see. A skier begins skiing straight down a hill, having a constant slope starting from rest. If friction is negligible as the skier goes down the hill, his or her, all right, so this is a no friction problem. This guy's going down a hill with the skier, let's see. All right, and so he's going to accelerate. And so since this is just like our lab we did, we know that the acceleration is usually constant unless there's some other friction going on. So acceleration increases is out. You should remember from our lab. And then so that leaves us 2. It's not 0. Is the value more or less? Well, if you have to remember the acceleration of gravity, which would be straight down, is 9.8. So since we're not going straight down, we're going to be less. So that would be an A. Number 2, a person in a car is driving down a straight road. The instantaneous acceleration is decreasing with time, but is directed in the direction of the car's motion. The speed of the car is, okay, so this has to do with this whole graph of, if we have an acceleration versus time graph, the car is accelerating because it's directed in the direction of the car's motion. So the acceleration is positive, but decreasing. So the acceleration is positive. If your acceleration is positive, that means your velocity is going to be increasing. So the velocity is going to be increasing. It may be curving and eventually start to get flat as this acceleration gets to 0. But it is going up the whole time. So the acceleration is increasing with time. Careful there you don't mix up the differences between acceleration and velocity. All right, so those first two. Let's do another one. A child is standing on a bridge, throws a rock straight down. Okay, so now we have something where an object is getting thrown straight down, which means it's going to have an initial velocity that's not 0. All right, and then once it's thrown, gravity is going to take over. So we got a gravity. So the acceleration is going to be 9.8 if we're saying down is the positive direction. So it has initial velocity and the velocity is positive. If we look here, they say which graph represents the velocity. Well, we have this whole positive or negative thing, and they didn't say which is up or down. We know the velocity is not starting at 0, so B's out. We're not at 0. And then it leaves us, this one's out too. That one starts at 0, so E's out. And that leaves us with D or C or A. All right, if the acceleration is constant, because it's just 9.8, that means we're going to get a straight line for velocity graph. So these two are out. So that leaves us with 2. Which one best represents the velocity with time? So this has this question, are we starting with a negative velocity or a positive velocity? And that one, you kind of have to use your judgment which one you think would fit better. If I said my acceleration is down is positive, then I would be starting with my initial velocity is down is negative, and I'll be going increasing down. But I'd say my initial velocity was positive and then increasing. Of course, here the velocity is changing direction, so that means it's going from up to down. So since we have a change in direction here, that one makes sense. So that means we're going to go with C, because it's starting with a velocity and then it's always going down. So this would always be there's no direction change. It's always going to be on the negative side. When we go from positive to negative, that would mean a change in direction, which wouldn't fit this problem. So that one's a little tricky. Hopefully you could narrow it down to A or C and then have to puzzle through that. We'll keep going. Number 4, the plot below shows the position of an object as a function of time. Okay, so remember here, we always got to make sure these graphs, this is position, get that in your head, it's where it is. The letters H through L represent particular moments of time. At which moment in time is the speed of the object the highest? Well, on a position time graph, the slope is equal to the velocity. All right, now velocity includes direction. So a positive slope would be a positive velocity. This one just says speed. Speed does not include direction. So we're looking now, we need the slope, but we don't care if it's positive or negative. Where is the maximum slope? So it looks like here, this is definitely the steepest in here. So it looks like J is where it has the steepest slope, either positive or negative. All right, I'll pause that here.